Hi, my students in grade 9, a new mathematics lecture today. It's lecture 5 with the title of Inequations. What are the objectives of our lesson? Number 1, identify an inequation. Number 2, inequality symbols. Number 3, check whether a given value is a solution of an inequation. Number 4, solve a first-degree inequation in one variable. Number 5, represent a solution of an inequality graphically. Number 1, identify an inequation. An inequation or inequality, it is similar to the equation. It is a mathematical statement formed of two sides or expressions using one of the symbols less than, greater than, less than or equal, greater than or equal. While in the equation, we use between the statements and equal. For example of inequations, 2x less than 5, this is an inequation. On side 1, we have 2x. On side 2, we have 5. In between, we have the symbol less than. X squared minus 4 greater than 0. On the first side, we have x squared minus 4. On the second side, we have 0. In between, we have greater than. Half x plus 2 greater than or equal minus x. On side 1, we have half x plus 2. On side 2, we have minus x. In between, we have greater than or equal. Number 2, inequality symbols. 1, A less than B. So we read it A less than B. As an example, A less than 4. What does this mean? A can be any value less than 4, and 4 is not included between my values. What are the values less than 4? 3, 2, 1, 0, minus 1, minus 2, minus 3, etc. I have infinite solutions. But one of my solutions is this, but it cannot be 4. That's why we say 4 is not included between my solutions. Number 2, A less than or equal B. So it can be less than B or equal to B. So A is less than or equal to B. As an example, A less than or equal 4. What does this mean? A can be any value less than 4, and 4 is included. Why? Because we have or equal. So my values of A will be equal or less than 4, 4, 3, 2, 1, 0, minus 1, minus 2, minus 3, etc. Infinite solutions. 3, A greater than B. As an example, A greater than 4. So A can be any value greater than 4, but 4 is not included. What are the values greater than 4? 5, 6, 7, 8, 9, 10, etc. But 4 cannot be one of my solutions because here I do not have or equal. The last one, A greater than or equal B. As an example, A greater than or equal 4. So A can be any value greater than. Here I have a typing mistake. This is not less than. This means A greater than can be any value greater than 4, and 4 is included. Why is 4 included? Since we have or equal. So this is greater than 4, and 4 is included. So 4 can be one of my values, 4, 5, 6, 7, 8, 9, etc. until you finish. Let me erase it. So these are the symbols of inequalities. I will continue. Solution of an inequality. As we can find the solution of an equation, we also can find a solution of an inequation. So sometimes we will be given an inequality, and we should check whether the given value of the variable is a solution of the given inequality. What should I do? I replace the given value of the variable in the inequality. The given value of the variable is a solution if the inequality is true. What do I mean? Check if -1 is a solution of the inequality 2 into x minus 1 less than or equal minus x plus 4. So the given value of x is -1. I replace x equal -1 in the inequality. Let's replace. In place of each x in the inequality, I replace it by -1. So we replace x by -1 and we replace x by -1. Why did I replace x -1 between parentheses? Since I have minus before it. Now I calculate side 1 and side 2. So I ask 2 into -1, -1. Is it less than or equal minus into -1 plus 4? So here I write a question mark on the symbol because I'm checking. I calculate side 1. 2 into -1 minus 1 is -2. And minus into -1 is 1. 2 into -2, is it less than or equal 1 plus 4? I don't know. If I multiply 2 times -2, my answer is -4. 1 plus 4 is 5. And I ask, -4, is it less than or equal 5? Yes, it's less than 5. So my inequality is true. Then I say x equal -1 is a solution of this inequality. Let's check if 3 is a solution of this inequality. So also I replace x equal 3 in the inequality. So 2 into 3 minus 1 less than or equal -3 plus 4. Is it equal to the two sides? Let's calculate. 3 minus 1 is 2. So 2 into 2, is it less than or equal minus times 3 minus 3 plus 4? 2 times 2 is 4. Is it less than or equal 1? Is 4 less than 1? Of course, no, it's false. So x equal 3 is not a solution of the inequality. Let's solve a first-degree inequation in one variable. To solve a first-degree inequality in one unknown or in one variable is to determine all the solutions of this inequation. Let's solve 2x plus 4 less than minus x plus 1. This is a first-degree inequality since the exponent of x in the inequation is 1. As we did in the equation, we take all x to side 1, all numbers to side 2. And as we take from side to side, we change sign. Minus x, I take it to side 1, it becomes plus x. Plus 4, I take it to side 2, it becomes minus 4. Let's calculate each side. 2x plus x is a 3x, less than 1 minus 4 is minus 3. Now I divide my inequation by the coefficient of x, which is a 3. 3x divided by 3, it gives me x, less than. Minus 3 divided by 3 is minus 1. So x is less than minus 1. So x can be any value less than minus 1. For example, -2, -3, -4, etc. 5 minus 3x greater than or equal minus 5x plus 11. Minus 3x plus 5x greater than or equal 11 plus minus 5. Plus 5 becomes minus 5. Now minus 3x plus 5x is 2x greater than or equal 11 minus 5 is 6. Now divide all the inequality by 2. 2x by 2 is x, greater than or equal 6 by 2 is a 3. So x can be any value greater than or equal 3. Is a 3 included? Yes. Why? Because it has or equal. So x can be 3, 4, 5, 6, 7, etc. Here, -1 is not included because we do not have or equal. 5x minus 4 greater than 8x plus 5. 5x minus 8x greater than 5 plus 4. 5x minus 8x is minus 3x greater than 5 plus 4 is 9. Now I look at the coefficient of x. I can see that the coefficient of x is negative. If the coefficient of x, as the examples above, is positive, I divide by the coefficient of x and I continue normally. While if the coefficient of x is negative, I cannot divide by a negative coefficient. So I should change my negative coefficient into a positive coefficient. I multiply the whole inequality by a minus. Negative 3x by minus is a 3x. When I multiply the inequality by a minus, I flip or switch my symbol. So if it is greater than, it becomes less than. If it is less than, it becomes greater than. If it is less than or equal, it becomes greater than or equal, and so on. Now the coefficient of x is positive, so I divide the whole inequality by 3. 3x by 3 is x, less than minus 9 by 3 is minus 3. So x can be any value less than minus 3, and minus 3 is not included. Here I have a fraction, as you can see, minus half x plus 3 greater than or equal x. Whenever in an inequality you have a fraction, so all the others should be written as a fraction. So 3 should be written as a fraction. I write it 3 over 1, and x, I write it x over 1. My denominators should be like. So I multiply 3 over 1 by 2. It becomes 6 over 2. Now here I have like fractions. Also on the second side, I multiply the fraction x over 1 by 2. So x by 2 is 2x and 1 by 2 is 2. Now, as you can see in this inequality, on the first side, I have denominator 2. On the second side, I have denominator 2. So I write minus 1x plus 6 over 2 greater than or equal to x over 2. Since I have the same denominators on both sides, I can cancel them. So I simply write minus x plus 6 greater than or equal to x. Now all x to side 1, all numbers to side 2. Minus x minus 2x is minus 3x, greater than or equal minus 6. Now, since the coefficient of x is negative, so I multiply the whole equation by minus. Negative 3x by minus becomes a 3x. Greater than or equal becomes less than or equal. Minus 6 times minus is 6. Now the coefficient is positive. I divide by 3. So 3x by 3 is x. Less than or equal 6 by 3 is 2. So x can be any value less than or equal to. And 2 is included. So my values of x can be, or my solutions of x can be 2, 1, 0, minus 1, minus 2, etc. Here I have an important remark which I discussed while solving the inequalities. If the coefficient of x is negative, I should change it into positive. How? Multiply the whole inequality by minus to change the coefficient into positive. But flip symbol. What do we mean? Or switch. Flip less than into greater than into less than or equal into greater than or equal, and greater than or equal into less than or equal. Now, after I solve my inequality, I should represent the solutions of my inequality graphically. And I should write an interval. So I should locate the solution obtained on a numerical axis or on a numerical line. Then I write an interval. Suppose my solution of the inequality was x less than 2. I draw a line with a ruler and I put an x wherever I like, and I write 2, the obtained solution. Always here, if you still remember while I'm solving, I was saying, always I was saying, etc., for the solutions of the inequality. This etc. means my solutions are infinite. So here on the number line, I always write a minus infinity and a plus infinity. Minus infinity means my numbers never end in the negative, and plus infinity means my number never ends in the positive. So I have x less than 2. So 2 less than going towards the negative. So going towards the negative infinity. Here, since I do not have or equal, so I should use the interval, which is open interval. And how do I draw the open interval? The open interval has a back and it has a hands. It has two hands. If I do not have or equal, it should be opened. How do I draw it? I give the back to the number and the hands are going to the other side. So x belongs to minus infinity until 2. And 2 is not included since my parenthesis or my interval is opened. Always on the minus infinity, the interval should be opened. It's never closed. Why? Because infinity, minus infinity means it never ends. So it's opened. Now I have x less than or equal to. The same, I draw a number line, minus infinity plus infinity, and I write my solution too. Less than means going towards the negative infinity. Now, since I have or equal, my interval should be closed on 2. How do I close it? I hold the 2 with my hands. So my hands should be drawn towards 2 and the back outside. My interval should be x belongs to minus infinity until 2, and 2 is included. That's why it's opened on the minus infinity and closed on the 2. Always on the minus infinity and the plus infinity, we have an open interval. X greater than 2. The same thing, I draw an axis or a number line. On the number line, I have minus infinity and plus infinity. Since my numbers never end in the negative and the positive, I write my solution, which is 2. Since it's greater than 2, so it's going towards the plus infinity, towards the positive. So I draw this arrow going towards the positive infinity. I look here, do I have or equal? No. So my interval should be opened. So my hands are drawn outside. And this is opened on the 2 and opened on the plus infinity. Now x greater than or equal to, so also I draw the number line, negative infinity, positive infinity. I write my solution. It's closed on the 2 since I have greater than or equal. Going towards the positive infinity, since it's greater than 2, it can be 3, 4, 5, 6, etc. And on the plus infinity, it's opened. Also, my solutions can be between two numbers. X is between minus 2 and 3. So I write the solutions minus 2 and 3. My solutions are between. It's opened on the 2 and opened on the 3. That's why I draw opened intervals on the minus 2 and the 3. My solutions are between. Which values do I have between minus 2 and 3? I have minus 1, I have 0, 1, and 2. Minus 2 and 3 are not included. That's why they are opened intervals. The others are the same. As you can see, if I have or equal on both sides of my solutions, so it's closed on the 2, it's closed on the 3, minus 2 and 3 are included. So what will be my solutions here? Minus 2, minus 1, 0, 1, 2, and 3. Here my solutions are minus 1, 0, 1, 2, 3 is included. This was this is the last slide of our lesson. As we have special solutions in equations, I have special solutions in inequations. The first special solution, x has infinite solutions or many solutions. For example, 2x minus 4 less than 2 into x minus 1. 2x minus 4 is less than 2x minus 2. Let me correct it. So this should be 2 because I multiply 1 for all. So this should be 2. So I have 2x minus 2x. And here I get the 4. And here I have minus 2. So 2x minus 2x is 0x, less than 4 minus 2 is 2. Now 2x less than 2, how do I mean x has infinite solutions? This is always true. Why? Because whatever the value of x is, 0, positive or negative, it's always less than 2. Let us try. 0 times 0 is less than 2. 0 times 1 is less than 2. Why? Because any number times 0 gives me 0. And 0 times minus 10, for example, is also 0 less than 2. And here I have infinite solutions. So my solutions can be any negative, any positive, and 0. Here in number 2, x has no solution. Also here, if I solve my inequality, I have minus 2 minus 3. So 2x minus 2x is 0x, and minus 2 minus 3 is minus 5. So here it has no solution. Is 0 less than minus 5? Of course, no. So x has no solution. This was the last slide of our lesson. And as I always say, when you are watching this video, solve again what I solved on the slides as examples before start solving the worksheet to understand the lesson well. And if you have any question, contact me, please. Thank you.